Hi, so in this video I'm going to be talking to you about ionic bonding. So this is between metals and non-metals and involves the transfer of electrons. So I've got my example on the board. We've got sodium, which is our metal, and I'm going to use chlorine, which is our non-metal. So sodium, one electron in its outer shell, it's in group 1, and we've got chlorine, which has 7 electrons in its outer shell and is in group 7. So as I've mentioned, ionic bonding involves transfer of electrons. So our metal atoms like to lose their outer electrons, and our non-metal atoms like to gain these electrons in order to get this full outer shell. So sodium is going to lose its 1 electron from its outer shell, and it's going to transfer this over to chlorine to make a chloride ion. So because sodium has lost its electron, it has lost some negative charge, so it becomes positive. Our chlorine atom has gained an electron, so it's gained some negative charge. So our chlorine atom becomes a negative chloride ion. So now we have a positive ion and a negative ion, so 2 oppositely charged ions, and there is an electrostatic attraction between the 2 of them. So because we've got a positive charge and a negative charge, these 2 are attracted and form a bond with each other. So they don't just stay like this. There's lots of ions kind of repeating again, forming a nice regular 3D structure, and this regular 3D structure is known as a giant ionic lattice. So what you would see in an ionic structure, you would have positive ions next to negative ions in a nice regular arrangement in a 3D structure. So in this particular example, we have 1 sodium ion and 1 chloride ion attracted to each other. So our formula for this particular compound would just be NaCl, because we only need 1 positive chloride ion and one positive sodium ion and a negative chloride ion. So it would just be NaCl. So the diagram I've used to show our ionic bonding is known as a dot cross diagram. So basically, because our sodium electrons are shown as crosses and our chlorine atom electrons are shown as dots, and this just helps you to see kind of where or how the electrons have been transferred. So this is a common representation for showing ionic bonding. So you can either show it as a dot cross diagram, or you can just write it out as the formula that we've written down in pink. So another example, we're going to use magnesium as our metal atom, and we're going to use chlorine again as our non-metal atom. So this time we've got magnesium that's got 2 electrons in its outer shell. Chlorine, same as before, has 7 electrons in its outer shell. Again, magnesium is shown with crosses and our chlorine is shown as dots. So magnesium is the metal, it likes to lose those 2 electrons. So we've lost the negative charge and we become a 2+ ion because we've lost 2 electrons. So now we need to transfer those electrons. Chlorine actually only needs one of those electrons to have a full outer shell. So we need to get something else involved. So the chloride ion is negative because it's gained this negative charge, but we've still got one electron that needs to go somewhere else. So we get another chlorine atom involved. So magnesium's lost those 2 electrons. One has gone to one chlorine atom and created a chloride ion. Then the other electron can go to another chlorine atom and again form another negative ion. So because magnesium lost 2 electrons and we needed 2 chlorine atoms to transfer those electrons to, we've now got 1 magnesium ion and 2 chloride ions. So if we wanted to write that out as a formula, we'd need 1 magnesium Mg and 2 chloride ions, so Cl2. And as a dot cross diagram, we would need to draw out the 2 chloride ions as well as the magnesium. Now you will have noticed that in this example I've only used the outer shell, and that's all you need to draw. You only need to draw the outer shell, or